recognizing examples and non-examples of the Pauli exclusion principle. In this example problem, it says which of the following are not valid quantum numbers. So we have to look at all the quantum numbers, the 4 quantum numbers we have here, and see if they could actually be an electron. So A, we have A here. It says the principal number is 2, so it means it's an energy level 2. It is in the p orbital because that number 1 represents the p orbital. And then here it says 2. What we have to remember about ML is that ML only ranges from negative L, so what L was before, negative L, 0 to positive L. So since in this one it says that L is 1, that means it has to be either negative 1, 0, or positive 1. And unfortunately, this doesn't say that, so A is not valid. So it is one of the answers we're looking for. So A is another not valid one. B, it says N is 2. That's great. However, here it says L is 2. That's problematic because here we know that L can only go up to what N is. So it can only go up to what N is, but it can't be N. It can run up right next to it. So here it says 2, then that means that L has to be 1. This makes sense because 2 stands for a d orbital. 2, when you see it in an L, stands for a d orbital. However, 2 only has s and a 2p orbital, and so that one is also not a valid quantum number, so that doesn't work. Now C, let's take a look at it. 3. Now this number is lower than 3. That's good. So check there. However, this is negative 3. Again, remember, ML only goes up to what L is. So since L is not 3, this number cannot possibly be negative 3. So that is another one we're looking for. So A, B, C are the ones that don't have valid quantum numbers. Let's check D and E. D has 3. This is 2. This is less than 3. That's great. This goes to negative 2, which is up to L, what L is. So that's check. And it has a positive 1/2 spin. That's a valid quantum number. Here we have 3. This is 1. That's totally possible. This is 0. Definitely possible. And negative 1/2. So that is valid quantum number. So those are not the answers we're looking for. A, B, C don't have valid quantum numbers, and those are the answers we're looking for.